Hello guys, welcome back. Today's video number 2, is a direct continuation of the work that we did last time in video 1. I've got the same example that we looked at last time. This was fully worked out in video 1, so make sure you have already seen video 1 and you know how to do this problem. Today we're going to do some very similar problems, but here they'll be for p hat, sample proportions. Let me remind you, up at the beginning, I mentioned there are two really important distributions we think about with these, x bar and p hat. We want to be able to answer questions about both of them. And last time, we did examples for x bar. And that makes sense when you're talking about quantitative data, anything that's a number. Today we're going to do the same thing, but for p hat. P hat, in other words, the sample proportion, is what we use to summarize categorical variables. So let's take a look at an example. One thing I really want to emphasize with these questions is that they all involve a probability for a sample result. Here, take a look at this problem that we solved yesterday. This one says we're taking a sample of 45 students. What's the probability that their mean blood pressure is more than 68? That's key. This question is all about samples. And I wrote that down here too. This was me kind of doing a mathematical translation of what this question is asking for. What's the probability of getting a sample result like this one? Now, in these examples yesterday, we were talking about heart rate. And heart rate is a quantitative variable. How about today, let's move on and do another example involving p hat. This one's going to be a forwards problem, and it's about gender. Gender is a categorical variable. There's no way to quantify or count gender. So we need to use sample proportion. And in this particular problem, we're talking about the proportion of students who are female. That's the category in question, female students. The setup here is very similar to what we saw last time. We're taking a sample of 100 students, and we're wondering what's the probability that at least half of them are female. Just like last time, this is a question about a proportion, about a sample result. It's a question about a sample result. So we're going to need to use our sampling distribution. Maybe let me make a note of that. Note, it's about probability of a sample result. So we use a sampling distribution. That's what I'm thinking as a student when I work through these problems. All right, well, let's get some of the important information down here. What do these numbers tell us? It says about 51% of all Denison students are female. That's the population proportion. Think in your head. What's the mathematical symbol for the population proportion? Jeopardy theme song is playing. Or you can pause and think about it for as long as you want to. Well, it's P. P. P is the population proportion. That's the percentage for everyone. And here, this problem tells me that P is equal to 0.51 because 51% of all Denison students are female. Okay, cool. We also see that we're taking samples of size 100, so I'll make a little note there, n equals 100. Okay, now that's what the problem told us. What's the problem asking us to do? It's asking us for a probability. And specifically, we're wondering about the probability at least half. It doesn't say specifically that it's a proportion, but you know that it is because we're talking about categorical data. So I'm going to say p hat is at least 0.5. In other words, i.e., sample proportion is at least half. 50% is half. That can be kind of a tricky detail too, by the way, when you're solving a problem. This question didn't specifically say 50%. So you have to think about that a little bit when you're working the problem on your own. Especially, this is a great example of how, on a quiz, you might get stuck on something like that because under the stress and tension of taking a quiz, you might not realize half is a proportion, 50%. So those little details are exactly why you just have to practice these things. There's lots of them, and the only way you can spot them is by doing lots of examples, like this one. Okay, so we're going to use the sampling distribution. One thing I might wonder, I think it should have a normal distribution, right? Question, does p hat have a normal dist? Now, the central limit theorem tells us it should, as long as our sample size is big enough. So is our sample size big enough? Is our sample big enough? If it is, we're good to go. But we need to check this thing. And for proportions, it works a little bit different. Last time you saw with means, we need n to be at least 30. Here, we need to check n times p, and also n times 1 minus p. So let's do that. Let's check. Our answer here, check. We need np bigger than 10, and n times 1 minus p to be bigger than 10. And you can see those numbers for n and p, those are just right up on my screen there. We know p is equal to 0.51 and n is equal to 100. So I'm going to use my calculator here. For the one of them, that's 100 times 0.51. For the other one, that's 100 times 1 minus 0.51. And I'm going to run both of these things together. I can see the first one, of course, this math is pretty easy to do in your head, 51. And the second one is 49. So yes, we are good to go. These things are big enough. Yes, both are bigger than 10. CLT says p hat is normal. We're good to go. All right, so if we're going to use a normal distribution, then, of course, like always, we are going to need to get a z-score. You know what z-scores are all about. Z-scores are observed minus expected divided by the standard deviation. But here, we've got to use all of the stuff for proportions. And I want to remind you, the answer to what all of these things are, I put that right up at the beginning of these notes. Let me show you. Here. Here's where we need this stuff. Specifically, this stuff. These are the two important things. It tells us what our expectation is, the center, mu of p hat, and it tells us what the standard deviation is. So let's use them. Our expectation is p, the population proportion, and our standard deviation, it's kind of long and nasty, but oh well, that's not too bad. It's the square root of p times 1 minus p all over n. So let's use it. Where are we? Here we go. Let's get our z-score. Our observed sample proportion that we're talking about is p hat equals 0.5. That's the sample that we're thinking about in this problem. We're wondering what's the probability of getting a sample result that's at least that big. Our expected in this one is p, the population proportion, just like we saw up above. So that's P equals 0.51 because 51% of Denison students are female. And what about our standard deviation? For the standard deviation, that's sigma p hat, and that's the square root stuff. Square root p times 1 minus p divided by my sample size. There's all the important pieces of info. We've got our observed, our expected, and our standard deviation. So I'm going to plug all of those into this here z-score formula and see what we get. By the way, this would be an excellent time to pause the video, try this on your own with your calculator or whatever you're going to use for the quiz, and see if you can get the answer right. I'll do it right now. Okay, on top, that's 0.5 minus 0.51 divided by all the bottom stuff. Square root 0.5 times 1 minus 0.5 divided by 100. We've got a z-score here of negative 0.2. Did you get the right one? If you didn't, try again. You can see my work there. A couple of little pointers about this calculation that I've seen students make mistakes on before. For the standard deviation down here, that should be the population proportion. Crap. So, I realized that I've made a mistake. This should be the population proportion. Let me point out to you, how about well, this is awkward, isn't it? Okay. Here's a good exercise, though. Can you pause the video and see what mistake I made? I plugged the wrong number in. I'm sorry, all my brain power is going to making this video. I made a mistake. Can you see what my mistake is? Let's see. In the standard deviation, let me come back to my slide. Here. This thing. I need the square root of p times 1 minus p. But that's not quite what I put in, is it? I accidentally used p hat. Here. I should have been using 0.51 there, so I made the mistake that a lot of students make sometimes. That's okay, it's a teachable moment, that's what we call it. So let me fix that. That should be p. And that should be 1 minus p. It's okay. That's a pretty easy mistake to fix. Maybe since I made that mistake, I'll make a note. Use p pop proportion in standard deviation, not p hat. It's an easy mistake to make, which is why I'm pointing that out. Let me run my code again. And I get, well, I guess it doesn't really change it very much, 0.20004. Okay, cool, that's fine. We're still going to use z is equal to negative 0.20 because we got to round this thing off to 2 decimal places. Okay, so we've got a z-score. Let's take a look at the table to see what the table says. And I've got it up in another window, so I'm going to flip over. Here's my table. I'm looking up where'd you go? Oh, here we go. Negative 0.2. There it is. And my second decimal is 0, so there's the thing I'm looking for in the table. Here's exactly the same table you've got. Don't worry if you forgot to bring your Z table home with you. This is the one that's in the back of the book, so you can still access this. I've got a value of 0.4207. In the table, probability that Z is less than negative 0.20 is equal to, what is it, 0.4207. In my notes last time, I used the pnorm command, which does exactly the same thing, pnorm of negative 0.2. This gives me a few more decimal places of accuracy, but it's still the same number, 0.4207. You can do either way you want. on the quiz, if you want to use R and use p-norm to find out your probabilities, that's totally fine too. I'm not there watching you, so there's no way I can know. However you feel comfortable is totally fine on the quiz. So we've got our probability, but be careful, this isn't quite the final answer because our problem, if I recall, said at least, says what's the probability that at least half of them are female. So here, we got it backwards. We did less than, and we need a bigger than one. That's cool. It's easy. At least means bigger than. So do 1 minus. And for us, our final answer is 1 minus 0.4207. Let me run that in there and type a sentence. There's about a 57.93% chance that a sample of, how many students did we have? 100? It was 100, right? Yeah, 100. Sample of 100 Denison students is comprised of at least half female students. The end. We have answered a probability question about a particular sample result. It seems like this is a pretty normal, how about, let's get some human feelings in there. This is a very common result. In other words, it is not statistically significant. And that's the end. We've answered this question about how likely a particular sample result is. Yay! Okay. Let's do one more example with this stuff. But for this one, let's do a backwards problem. Of course, this was a forwards problem because we started with a particular value, half, and we found a probability associated with it. Let's do a backwards problem. Here, same setup. Still about Denison students, and it's still true that 51% of Denison students are female. This question says, if we take samples of size 100, in what range would the middle 99% of sample proportions lie? Now that might seem like kind of a strange question to ask, but actually it's really practical. What it's asking is, okay, when we're taking samples, what kind of samples would we expect to see? If we look at the middle 99% of them, in other words, almost all of them, where would we expect these things to be? It's a backwards problem because we're starting with the middle 99%. In other words, this problem tells us an area, and we need to use that to find what the original value had to be. I'll make a little note of that. Note, we're given an area, middle 99%, need to find a value. Here, that's sample proportion. That's why it's a backwards. And it works like all the other backwards problems that we did. Let's imagine, sorry, I don't have a whiteboard, so we're imagining my face is a normal curve. My head is in the middle of the curve, and the two tails are on the outside. So if we're talking about the middle 99% of it, that means the two tails together have to have the other 1%. But we got to cut those things in half. So that's 0.5%. If middle 99%, each of the two tails has 0.5%. There's 1% left over for them, but we gotta split it evenly with the two. So that's 0.5%. Okay, so in other words, that's 0.00 5, we are going to need to find the closest to 0.005 in the table, and then get the z-score. It's a backwards problem. So let's do it. I've got the table up on the other page. I'm going to look for it. We are looking for 0.005, at least the closest thing that we can get. So let's see. It's going to be towards the top. And here's an example where two of them are equally good. There's 0.0049 and 0.0051. You can see the one I've got highlighted, right? Those are both equally good, so I'm going to split the difference and take the one in the middle. That's a z-score. If you look over in the margin, the first decimals are negative 2.5. For the second decimal place, it's got to be in between 7 and 8, so I'm going to use 7.5. Negative 2.575. Table tells us negative 2.75. Oh, sorry, I forgot. What is it? 2.575. Excuse me. We'll use both. Use both, plus or minus, for the two bounds. Because the negative one is over on the bottom side, and the positive one is the one that's over on the top side. We want to use both of them because we're looking for this range in the middle 99%. Remember, we've got the backwards z-score formula. We know here for proportions, for p hat, our z-score is p hat minus p divided by the square root of p times 1 minus p divided by n. So we need to solve backwards and figure out what p hat's got to be. We know what the z-score is, and we know what p is, and we know what all this stuff is. P hat is the thing that we're trying to get in this problem. We're going backwards. It's not too bad to do a little bit of algebra to get this by yourself, but I'm just going to tell you right now how to do it. If you do a little bit of algebra, you can get p hat by itself. It's z times, I wish you could see, I wish I could write on the board, p z times all the square root stuff. I'm going to multiply the square root stuff over, and then I'm going to add p over to the other side. So p times square root of p times 1 minus p all over n plus p when we add that stuff over. Here's the backwards z-score formula. Backwards z-score for p hat. By the way, it is totally okay for you to have this in your notes and refer to this formula when you take the quiz. You don't have to memorize this, and you don't have to figure it out again every single time. I'm telling you what it is, and you can use this on your own. Here, we've got a couple of bounds to get. I'm going to plug in all of our information. We've got the z-score, so I'll start there. That's negative 2.575. And then I've got times the square root 0.51. I'm going to be careful not to make the same mistake that I made last time. Times 1 minus 0.51. The sample size, what was our sample size here? Sample size 100. Did we do 100 for both of these? Let me make sure how we did. Okay, that's fine. Divided by 100 plus the sample proportion of 0.51. That's my lower bound. Let me mark that. That's the lower bound. And for the upper bound, same thing, only we'll use the positive z-score. Same thing, but we're using the positive z-score. I just copy-pasted without the negative sign there. The upper bound is 63 point something percent. So, in other words, 99% of the time, the sample proportion of female students would be between 38.12% and 63.87%. In other words, the work that we just did tells us what sorts of samples we would expect to get from a population like this. And this is true. If you took samples, random samples of size 100 of Denison students, about somewhere between, say that more clearly. If we took samples like this, there's a 99% chance that the percentage of female students would be between 38% and 63 something percent. We know what sort of samples to expect. And this is going to be the tool that we use to make the conclusions that we do a little later on. By the way, I realize that I have not had a secret quiz question. It is time for the secret quiz question. Are you ready? The answer to the secret quiz question for video 2 is Super Nintendo. I decided I'm not going to type it out here because then you wouldn't have to watch the video. You could just see the notes online. So I'm telling you, Super Nintendo, as in Super Nintendo. I had a Super Nintendo. Super Nintendos came out in 1993, so I was 10. That was a good summer, by the way. All right, so the secret quiz question is Super Nintendo. Make sure you actually try these questions out. Try to follow along with the math. Make sure that you can actually do these things with me. That's the only way you'll be able to get ready for the quiz. On the quiz questions for this Friday, I'm going to ask you very, very, very similar questions. Not like literally exactly the same. I might change the numbers a little bit, but they'll be the same sort of things where you find probabilities for particular sample results and also backwards problems where we find out what sort of sample results we would expect from a particular population. I'm also going to post practice problems as usual. They're going to appear right below the video. There's like a little summary paragraph about the video. You might have to click show more to see that stuff. But look, on this page, on this web page that you're on right now, there are practice problems. So take a look at those, okay? All right, guys. Thanks for playing along. See you next time.